What's up, everybody? Welcome to another episode of Archill Podcast. Today I'm joined with Giorgi Lekveishvili. It's his second time on the podcast, and today we're having a very special episode. 10 months ago, Giorgi was the very first guest on Archill Podcast, and by the end of that episode, we talked a bit about his side project. Today, I'm extremely excited that we can dedicate this whole episode to this amazing open source platform he's been building for quite some time now. His name is Dodo. And it's something like Heroku and Gitlab on steroids. So basically it's a cloud platform. And that's why we'll be having slightly more technical conversation today. As usual, don't forget to like, subscribe, and tell your friends about Archill Podcast. And now, without further ado, let's directly dive into our conversation with Lekwa. Enjoy. I know that you visited Zanzibar and just got back. And before we dive into this core tech stuff, can you tell us about Africa? How was it?
Oh man, yeah, it was pretty crazy, I would say. It was my first time in Africa in general, and the difference in the lifestyle of the people and the living conditions and everything. Like you see the full spectrum there. It's not as hardcore in Europe, I think. So yeah, it was really eye-opening, and people are like really happy despite the conditions they live in. Like it doesn't matter like, if they have money or not, they are still happy, and they are like just enjoying the life. Obviously, I'm simplifying it, but yeah, and the nature, yeah, amazing. We went to
Did you meet these animals like zebras and stuff?
yeah, zebras are like reds in Europe, like they are in every corner. We did the safari tour for a couple of days, and yeah, it was amazing. Like lions, zebras.
And I mean, is it dangerous or is it just you pass through the lions and
No, it was
giraffes and stuff?
safe. Yeah, you are driving in a car, so if you see that there is a risk of something happening, you can just always speed up, close the windows. So you should be safe. Obviously, you can make mistakes, but if you are with a knowledgeable guide, I think it's pretty safe.
Okay, awesome. So now, before we dive into our kind of primary conversation, I want to mention two small wins, like you and I had throughout last 9 or 10 months, because you were guest on my first episode, and by the end of the episode, we talked a little bit about your side project, which we're gonna talk about in this episode, and I think it's kind of a win for you that you didn't stop and you kind of moved it forward, and eventually you just got some working thing which our listeners will witness in this episode. And on the other hand, I also didn't stop, and you're after 9 months still guest on my podcast, so it's pretty amazing to see us both doing some stuff throughout these months. So now, as I know, the name of your project is Dodo, right? First of
Yeah.
all, why Dodo?
So internally, before I actually decided to actually publish the project, I was calling it P-Cloud, short term for the private cloud. But that's too technical name, I think. So I started thinking of some easy to remember, easy to pronounce words, which would be also gender neutral, because I'm planning of adding some AI assistance capabilities later on. I mean, AI is a buzzword nowadays, so it's not just because I want to join that buzz, but rather, I mean, I think there can be really useful features added to the system by adding support of the AI or machine learning. And so I was thinking maybe the name of the assistant should be also the same as the name of the project. So I wanted to find some gender neutral name. And I was just talking with my wife about it. And yeah, it was one of her first suggestions, actually very first suggestion, I think. I had few other ideas, but all of them were taken. So, and I liked it because it's also a Georgian name, and it's actually a gender neutral name in Georgia. You can find both males and females with that name, and it's the name of the bird, which is pretty cute. And yeah, I don't know. The moment you said it kind of clicked with me, and yeah.
Actually, it's pretty catchy and very simple to remember. So I like the name. Okay,
Yeah.
now just to put like the name history aside, can you tell me what is Dodo?
Yeah, so it's a many things, but at the core of it, it's a platform as a service, let's say, which lets the users, owners of this platform, to manage not only their data, but the applications who process this data, and let the applications share the data between each other in a secure way. So initially, I was thinking of just building something for my own home lab, where it would let me to easily launch the DNS server, email server, some image backup service, things like that. So I worked on that for a couple months at the beginning of pandemic, actually, and kind of proved to myself with the prototype that something like that was feasible. But eventually, as I started more and more adding more and more features to the system, I realized I needed some development tools to develop Dodo. So initially, I was using the GitHub for code hosting, that kind of stuff, but code reviews workflow on GitHub, I think, is pretty bad. It's just became de facto standard, and no one really thinks about how much it can be improved. But once you see that there are better ways of doing the code reviews, then you can't go back to GitHub. So I needed tools like that, tools like for code review, CI/CD, that kind of stuff. So I started adding this kind of features slowly to Dodo itself, and then like half year ago, I moved the whole development of Dodo on Dodo itself. So we are self-hosting the code, doing the code reviews on Dodo, running tests on Dodo, doing releases from there, having a communication between the team members using the services installed on Dodo, and we are kind of like fish fooding the product. So, and then like at some point, I realized all these tools I'm adding to the system can be useful for the other teams. Like obviously the big companies, they have their own like in-house solutions for all of these things. But if you're a small startup or a medium-sized company and you want to develop some software, you'll need all these tools. And nowadays, what you have to do is you have to either yourself or find someone who knows all these external tools to use, and then you have to pretty much dedicate at least a single person, if not more, depends on the company size, to just assembling all these tools externally and then tying all of them up together, which is just waste of time. I think like if there was a one product which combined all of these things together in a nice and coherent way, then you wouldn't have to spend time on just duct taping things to each other. So so I realized like Dodo could be useful for those kind of companies as well, and decided to actually form a company around it and try to sell the product. So that's at the core of it.
Okay.
Yeah,
Can
we
can I
can.
ask a
Yeah,
follow-up
sure.
question? So what you're just telling me is something like GitLab plus some cloud stuff and like all of those development kind of cycle things which are involved
Yeah.
from like writing code to release. So what's the difference between like those things, like for example GitLab and Dodo, for example? So
Yeah, good question. So like there's nothing new, I would say, in Dodo, like extraordinarily new. Like all of the services we are building or importing from the third-party projects, they already exist, and anyone can start using them at any time. It's just you have to learn all of these tools separately. Some of them have like really steep, high learning curve. For example, if you want to run a mail server for the company for some reason, I mean, you have to be pretty much the Linux admin. So, and that's not, I mean, even experienced developers don't really know how to administer the systems and secure them. So, there are existing tools like that. Gitlab is one of them. There are others like SourceHut is also one of them, but not. I mean, they all of them provide just subset of what Dodo does. Dodo is kind of a superset of all of these things. So if you use some other tool, I think you have to, just one tool isn't enough. You have to start like find something else which suits your needs, and then you have like n number of tools, and then you have to figure out how to configure all of them so that they can kind of integrate with each other in a coherent way. And yeah, I think that's just too much friction there. So one of the main selling points for Dodo is, I think, that it's kind of all-inclusive. You get, first, there is a platform which lets you do lots of abstractions on top of, and then slowly, if there is a tool you are missing from Dodo, it can pretty easily be added to the system so that it automatically integrates with the rest of the infrastructure.
Okay, I just wanted to ask that, so you just answered.
Yeah, so obviously I'm trying to, in the first version of the product, to cover most of the needs of the development companies, but obviously I will not cover the 100%. There will be tools missing, but I'm hoping that's okay, because I believe if I build the infrastructure in the right way, then these new tools, like someone, if not me, like some third-party developer, will spend a couple days to integrate existing tool into the Dodo ecosystem, publish it. We can talk about the details of how the publishing will work, but publish it, and then the rest of the world pretty much gains this new capability out of the box, and you don't have to. Every company doesn't have to spend and waste time on doing the same thing and reinventing the wheel from scratch.
Okay, actually, like I really wonder about the. I mean, so as you described to me right now, Dodo is some thing which can help us build applications, release them, deploy them, and like we will just grab some link and it will just work, right? That's what you described. Is that right?
Yeah. So one of the products, like sub-products of the Dodo, is kind of a Heroku-like system where member of the team can just like create a new repository for the new application, and this Dodo app will give the developer the like git clone command basically, and then you can clone it, make any changes in there, define what your environment for this application should be. Like, do you need a physical disk attached to your app, or do you want Postgres to be started externally, or maybe Redis for caching? You just declare what you want, not how you want to start those services, but what you want. And then Dodo takes care of spinning up all the services you require, spinning up your application, and giving you the pointers to these external services so you can actually talk to them. So this is like one of the sub-products of the Dodo, but there is like much more surface area there.
Okay, so I guess like before we dive into like core technical concepts, I think it would be best to just show our listeners actual demo of Dodo and how it works, how it looks. And actually, I won't lie, so I was like playing with Dodo for about a week now, and I'm a little bit familiar. So I think I'll share the screen and I'll show it from the user perspective, because I think I'm one of the first users of this platform. Yeah.
It's very basic, like lots of things can be improved, obviously, but
sure.
Otherwise, it's all there. So yeah, this is the kind of a desktop environment you enter once you log into the system. Yeah, and then
so on the left we have this like let's like walk through these two kind of options. But first, let's go to App Manager, and as I understand, this is just kind of some kind of an app store within Dodo, which lists some applications which we can include into our environment out of the box, right? For example, if we need Jenkins, if we need, some services, whatever, right? Is that right?
Yeah, exactly.
And the thing that you mentioned was that, for example, if for some company, some service or app is missing, they will be able to easily kind of integrate it into Dodo and include it here, right?
Yeah, yeah. We can talk about the details later, but
Yeah,
yeah,
exactly.
anyone can develop a software for Dodo or adapt already existing software to Dodo, which I did for all of these like open source projects you see on the
Okay.
screen.
Awesome. So let me just take for our demo purposes, my favorite app here. So this is basically like not like Jenkins or some project which is developed by others, but this is actually an app within Dodo developed by you, which is like something like Heroku, which lets
Yeah.
us build projects and kind of get links out of the box. So let's go to Dodo app. So I guess let's don't like pay too much attention to this configuration thing. So we'll just choose network public. I assume it means that it's just publicly accessible, right?
Yeah. Yeah.
Let me choose some domain like sub acho. Let's choose public network, and yeah, let's just leave this external box without checking, and let's install our Dodo app. So what's happening now is that it just spins some Git server, which is obviously controlled by Dodo itself, right? It's not GitHub, it's not some Gitlab or something, but it's Git server within Dodo.
Yep.
It creates some, I guess, some authentication stuff. It creates this HTTPS support out of the box, right? Immediately,
Yep.
what I see.
Yes.
Awesome. Great.
Yeah, while this is going on, maybe I can describe like actually what's going on in the background.
Yeah, sure.
We'll cover this later again, but like we have some time now.
Sure.
So all of this, like whenever installing an app from the App Store, what's happening is that the first thing the App Store does is it downloads all the necessary files to install this application local on the Dodo instance of the client, so that in future, for example, if the company who developed this software goes bankrupt and like doesn't publish binaries or configuration files anymore, since you already either bought or used the free software already once, you can always like reinstall the new instance of it in future, even if the original source of the application goes away. So all of these things can get committed committed to your local instance, and then you can reuse it as many times as you want. It's like in old days when you would buy a software, you would actually buy a physical disk, which you could install on any number of machines. Yeah.
Okay, for example, like if Jenkins, for whatever reason, decides to like get deleted or removed, if Jenkins was installed in your instance in Dodo, you will still be able to use it, right?
Not only use it, but you can create new instances of that same version of Jenkins as many times as.
Got it. Amazing. So now we get this view that everyone created, and we get this Dodo app. I mean, this Dodo app is like a sub application of this entire Dodo infrastructure, which we're looking at. And we go here, I guess, and we're presented this very simple UI. You know, like what I don't like about this huge projects like Heroku and stuff, that you get lots of information, lots of configuration, lots of stuff. Even though it's super easy to use Heroku, for example, here you just have like just 3 inputs and 1 button, and I love the simplicity. Okay, so we get this pre kind of chosen domain and technology. Let me choose like subgo, let's call it subgo, subdomain for our app, which we're going to create here. And yeah, these are right available runtimes for now, but let's stick with Golang and let's press create app. Awesome. So as I see now, this Git repository was kind of initiated, and now we can clone our Git repository with this boilerplate Golang code, right?
Yeah. So there are like multiple pre-configured templates of the applications you can install on Dodo. Obviously, you don't have to use it and like start from scratch, but to simplify the usage of the system, there are like a bunch of templates you can use. And once you create the app with a predefined template, Dodo pretty much populates the repository with some initial startup code, let's say, which you
Okay,
get.
awesome. Let me just, you see the terminal, right?
Yeah.
Yeah, awesome. Let me just clone. Yeah, I just cloned BST project. By the way, how do you come up with these names? I think it would be
So this
great
is
to enter, right? Those.
yeah. So there will be a way of actually naming the projects so that users
Yeah,
can choose
sure.
actually what the name is. But this is more of a project code rather than a name. So and these codes are
Yeah.
just generated like randomly, unique random strings, let's say.
And like what I love about Dodo is that lots of people like following this trap that they are building this project until like it's kind of ideal, and then they show it to the users. But you did it this completely different way. You just have like the first working thing with small bugs, small issues, etc. But you still gave it to me, and I think that's one of the most important learning, that like giving your product to users as soon as possible is super crucial, and
Yeah,
all these issues and problems are okay.
yeah. The thing is, so I've been using this for like at least a half year for the development of the Dodo itself, and um, as it's my own code, I know basically how to
Yeah.
navigate the bugs, and I usually either forget them if I don't write them down, or never really go back to and prioritize them if they are not like super critical to the system. And I think giving access early to the system to other people is important, so that even those small bugs will start like bugging you or bugging them, and then they will bug
Yeah.
you to fix them. And I
Exactly.
think you found like few of those last week, and I think we fixed pretty much most
Yeah,
of
yeah.
them.
Great. Okay, now let me just open our project in VS Code. And we just have pretty basic stuff. We have this main Go file, which just has this boilerplate endpoint. And yeah, so let me talk about AppQ with you later. Let's just get back to our Dodo page. I guess if I go to this page, right, this UI, this URL, I should be able to access our app, right? And
Yes.
basically, what we see is that out of the box, we got this HTTPS URL, which just points to the endpoint here, defined in this application, and it just returns hello from Dodo app, right?
Yeah.
And we just got that answer exactly. So that's pretty amazing.
Yeah, so we talked quite a bit during this process, but if we shrink all of this and just do the business, I think it takes minute max or two to get from nothing to basic working application, which you can then iterate on, which is, I think, for small companies who want to test the ideas quickly and prove them right or wrong, and maybe show the prototypes to the clients. I think that's very important to be able to test new ideas like super quickly.
Yeah, and what I'm gonna add here is that Dodo also provides this support for authentication and authorization, right, for endpoints. But we won't like show it right now because it might take some time. But it like all of your endpoints can be just secured right out of the box, and that's also pretty amazing.
Yeah, I can maybe talk a bit about it. So, like the first drop down you saw on the screen to choose the network where to install the application, it's we call it network in the Dodo, and you can, like, when you create an instance of the Dodo, you out of the box get one public network, which is your primary domain, the company's primary domain, let's say.
Yeah.
But then if you manage multiple domains, you can add all of those into the Dodo instance. Like in the App Store, there is the application to actually add the new networks to the system. And once you add them, then they become available to use by any of the applications installed from the App Store or the Dodo app. And each
So
network
here, right?
optionally,
Here.
yeah. And each network optionally comes with an authentication service out of the box, which implements the OAuth 2 specification. And so when installing the application into the network, users are always presented with an option to either require authentication to this application or not. And if you make it required, then you have an option of choosing what groups, users of which groups should be allowed and which should not. So you kind of define the allow list for the access. And out of the box, if you need the authentication in your application, you just check mark that box in the App Store or enable it in the Dodo app configuration in the Q file. And out of the box, you get all the authorization, authentication stuff implemented, and you don't have to worry about it at all. You don't have to go and use some out of the box, like outside external sources, like Auth0 or Google Auth or anything like that.
That's pretty amazing. And besides all this stuff we show right now, I think one of the coolest things is that Dodo also provides like storage out of the box, right? And can you tell us a little bit about this app.q file, which is a configuration file, and just tell us how we can use these storage capabilities?
So this is basically a JSON file. It's called Q because Q is a kind of a superset language of the JSON, but any valid JSON is a valid Q as well. So nothing crazy is going on here. Okay. And pretty much everything you can install in the application environment can be defined and configured from this configuration file. So for example, if you need a physical disk, like file system with your application to persist some data, which survives the restarts and crashes, you can define it here in the volumes section. If you need to store more of a relational data with your application, then there is a way to require PostgreSQL instance.
Actually, let me grab that config and just paste it so that we can also see how it looks like. So basically, if I add these two options, can you tell us what will happen?
Yeah, so these two are, first one defines physical disks you want to use, and second one defines the PostgreSQL instances you want to use. And each of them can be configured separately. So for example, the volume data and the PostgreSQL foo doesn't actually have anything to do with each other. So if we commit these two sections, you will get one physical file system attached to your application and externally started PostgreSQL with its own physical disk of size 2 gigabytes. And you'll get the address of that PostgreSQL server in your application, and then you can connect to it and select some data from it.
Yeah, I'll show that as well just in a minute.
And all of these things are kind of not singular. Let's say you can define as many volumes as you want and as many PostgreSQL instances as you want. If you need 2 PostgreSQL servers for some reason, you can do that as well.
And I think our listeners might be wondering, you just mentioned that this Postgres is allocated externally or something, and how that kind of creation of storage and stuff happens. And I think we'll be covering that in the final part of our conversation, where you will just explain to us the whole architecture and tech behind this infrastructure, right?
Yeah.
Awesome. Okay, so now let me guys show you how we can access and spin this PostgreSQL and make sure that it actually works. For that, I just asked GPT to generate some very small code in Go, which creates user table and lets us create user and then fetch all those users. Let's just install some dependency we need for that. And let me grab the code. And obviously, we need to add this Postgres configuration in Q file. And let me just just delete everything from main file and just paste GPT generated code, which should give us two endpoints. The first should be create user, and it should create user and persist it in the database. And get users should fetch all the users in the database. And now I can just commit all of these changes. Let's call it add Postgres example. Oh, sometimes even developers miss stuff in commands. And let's push it. And now this should trigger some kind of a process, right? Like
Yeah.
CI/CD or something like that.
Yeah, I can maybe go into a little bit of detail what's going on here.
Yeah.
So you remember there was a, like, once we installed the Dodo app, one of the items being installed in the system was a supervisor next to the Git server. So what the supervisor
Okay.
does is basically it just listens to all the pushes to the Git repository and processes them. So now it caught the new commit and reread the application appq file from the repository, analyzed it, and figured out that you need a PostgreSQL with your app. So if you click the commit link now, it will show you. Oh, you already, yeah, it's on the
Yeah, we
home page.
see.
So what it figured out is that you need a volume named data with size of like 1 gigabytes. There is another volume which was auto-generated because we requested PostgreSQL with a 2 gigabyte disk size.
Yeah.
So it automatically, analyzes the queue file, automatically figures out what kind of resources have to be created on the cluster. Apart from showing you all of this data on the nice UI, it will actually spin up the whole system, including your application, and tie
Okay.
all of these things together.
Okay, so now I guess we can try out creation of the user. So let me just check how it. So this is create user endpoint, and obviously for testing purposes, we just used get request so that I can test it from browser. So I can create user. So and user creation is done by just random names. So for simplicity, so user Charlie created successfully. Let's create another user. User Eve created successfully, and let me now check get users endpoint. And now it should return 2 users, right? So Charlie and Eve. And I think it's pretty amazing that it just took us a couple minutes, like 2 or 3 minutes, to spin up server with Dodo, create our application, add this Postgres support, generate very simple code with GPT, and just actually see it working, right? And kudos to you. Like, I think it's pretty amazing. Thanks.
Yeah, I wasn't sure everything would work seamlessly, but it actually worked. So yeah, I'm happy.
like I have this very funny story about demos and failure. So obviously, like for all of you guys who don't know, like was our lecturer, and there was this project, one of the subjects in the university where we were required to do this final projects, and we had these demos. Which was done virtually, like with the call, because COVID was at the time, and I remember like very precisely there was one button, I pressed it, and the whole screen went black during the final project demo, and we still passed it thanks to our great lecturer. But anyways, okay.
Yeah, I think it
So
happens to everyone. So
yeah,
no
usually things break during demos. So great. So now I think like the demo part can be over for us, and I'll pass the mic to you, and maybe you can explain to me how all of these things work under the hood and all the tech and abstractions behind it, because I think this is one of the most hardcore tech projects I've kind of interacted with lately, and so stage is all yours.
Yeah, let me share the screen. I just have like one slide, let's say, which kind of covers all of it. We can go as deep as we want into this tree.
But first, let's start from the very basics, okay? Just from top level.
So, like, if we zoom out a bit and don't concentrate on like what's actually going on under the hood, like the whole state of the system, like the Dodo, is represented as a tree data structure. So every application, be it installed directly from the App Store or applications developed by the developer and pushed to the Dodo by using the Dodo app ecosystem, all of those things, all of those actions, every action which changes the state of the system gets represented as a node in this tree. And at the root of this tree, we have just the entry point of the state of the system. And initially, during the bootstrapping phase, like we have this bootstrapping script, which takes raw Linux servers. You just give the few IP addresses and credentials to log in into them. And what this bootstrapping script does is pretty much starts assembling this tree. How this state gets then translated to the cluster resources, we'll talk about it later, but let's talk about what the state looks like first. So initially, we start with the empty root node, which doesn't have anything. And the very first things we install on the system is the network manager, which is responsible for allocating IP addresses and virtual networks to the.
So just sometimes I might interrupt you.
Yeah.
Every application is a node.
Yeah. So
is that right?
Okay. So let's talk about what the difference between these colors are. So
okay.
First, like the state is subdivided into subtrees. Let's say at the root of the tree, we have a subtree of the shared infrastructure of the platform. So services like who are responsible for generating the SSL certificates or creating the new instances of the Dodo live on this layer. And now what is the instance? So Dodo by default is the multi-tenant system, like any other operating system, be it Windows or Linux or Mac OS. It's a multi-tenant, meaning there can be like multiple users of the system existing at the same time concurrently and using the system concurrently. So instance of the Dodo is just one like sub infrastructure for one particular user, be it a company or the home lab user, let's say. So on the first root layer, top layer, we have the platform infrastructure. And as new users register into the system, we get new trees for each separate instance. And then link back to the root of the tree so that the whole system becomes like one big tree with the connections in between them. So so any change in the state of the system gets represented in this tree. So every application, every service, every disk, every Postgres instance, whatever gets installed on the system gets its own separate node on this tree. There are multiple ways of mutating this tree. So one is like first you have to create it, obviously, and this is taken care of by the bootstrapper. Then to create the new instances, we have this, we call it like Dodo env manager, which is responsible for creating these subtrees for every new instance in the system, and then linking it back into the main tree so that the whole thing becomes one connected big tree. So if you notice, like there is a connection, back connection from env manager to the root of the tree, so that once the env manager creates the new instance, it knows about this new instance root node and updates the main tree so that it adds the new kind of pointer to the new tree in there. This is env manager, and now about how all of this gets translated to the cluster, we can go into much details later on. But to talk about it briefly, one of the nodes on this tree is also the state reconciler, which pretty much watches the mutations on this tree. So every change gets pushed to this state reconciler, and its responsibility is to take this change, analyze it, and figure out how the services installed on the actual cluster needs to be changed. And to manage the cluster on the low level, we use Kubernetes. I used Kubernetes and low level in the same sentence, which is maybe not very common, but Kubernetes is itself like pretty complex high-level software. But for us, it's just one of the lowest level infrastructure pieces, which we use just for managing the containers and running containers on the shared pool of servers. So yeah,
just you just mentioned Kubernetes, and can we talk a bit about like what I see right now? It's just like one big instance and one big infrastructure of this application, which is called Dodo, right? This whole thing.
Yeah.
So is it like distributed on different servers, or where does this distributed and server stuff come in?
Yeah, so one of the things I like about Dodo is that it's distributed, fault tolerant, and persistent by default, high available by default. So there are similar projects living out there in the world. Like Unraid is one of them, for example, which is like really popular piece of software. But I'm not its user, but from what I read and I understand, it does have fault tolerance on the disk level, but on the CPU level, it's software which gets installed only one physical server or virtual server, doesn't matter. So yeah, if one of the disks dies, then data is replicated and you are safe that you won't lose the data. But if something happens with the CPU or there's a fire in the building and the whole server dies, then you lose all the data because it's self-contained and it's one server only. So if it goes bad, depending on how bad it goes, there's a potential that you will lose the whole state of the system. While in Dodo and other products, most of the products behave like that, like consumer grade products. But in Dodo, you start with a shared pool of servers. So you can have as many servers as you want. Each server adds to the system, contributes, let's say, to the system its own CPU resources and storage resources, be it hard disks on the NVMe drives. And all of these things like become accessible to the higher level software for Dodo itself via using the Kubernetes. So first thing that this bootstrapper script does is installs Kubernetes on this shared pool of servers in a high available mode. So if any one of the servers dies, then system still stays accessible. And so we leverage Kubernetes to actually run software on these servers. So in between the physical servers and the Dodo, there lives the Kubernetes, which we hide completely from the user. So in my opinion, Kubernetes itself is, while the implementation is pretty complex to use, once you learn it, it's pretty easy to remember things, but I think it has a pretty steep learning curve. So I didn't want to expose all the internal details to the user, so Dodo kind of swallows all of it and pushes only the clear and easy to understand it and remember APIs protocols to the users.
Okay, so like one question I have now is about scaling. So let's talk about this instance one, which is just visualized here. And let's say in the demo, what we did was some endpoint, right? We created some Dodo app, which created users, right, or something. So how does that service scale within this infrastructure?
So by default, so I still have to figure out the details, but as soon as I start selling this product, I will have to figure out the pricing, and depending on what kind of scale the user wants, I have to react accordingly and price the thing accordingly. So by default right now, you get one instance of your application, while disk is always replicated by default. So if your application dies or one server dies, you don't lose the data. But the access point, which is your application, right now we run only one instance of it. But it's just matter of one line configuration change in this appq file where you can increase number of replicas. And that change, once committed to the Git repo, will get reflected in this tree. And accordingly, that number of replicas of your application instance will run on the system. So if the load increases, you can just increase the number of replicas, and we can do that automatically as well. So you don't have to manually react on the changes in the load you get from the user. So we can listen to the traffic, and if we see that the traffic is increasing very quickly, we can automatically bootstrap new instances for you. Obviously, that kind of product will cost more to the users because we have to do some smart things to simplify the usage for the user. But yeah, it can be done manually or scaled out and scaled down automatically depending on the load.
Okay, so I still have like one problem understanding this big picture, which obviously is not simple. I think you worked a lot to create this thing, but so can we just talk about? So to me, there are some servers in the cloud which you are using, and this whole infrastructure is running on those servers, and you create kind of some server abstraction on top of those servers, right? Something like that.
Yeah, you don't actually. I hide the servers completely. You don't even have to think about the servers. So yeah, users don't think about the servers. Users just think about the instances of their applications, and we make sure those instances are automatically distributed on different servers for high availability and all that jazz. So servers become just a very low level concept in this system.
And for this scaling of very particular Dodo application, just like our user service we created. So let's say you run this whole infrastructure on 3 different servers under the hood, right? Let's say.
Yeah.
And then each of those servers which contain this Dodo infrastructure running contain our user service running, right? And is that how we do scaling here or somehow differently?
Yeah, we have, let's say, n number of servers, and the user requested x number of replicas. Then out of those n physical servers, x will be chosen, not completely randomly. We obviously take into account how each physical server is actually loaded at that moment. Like with the ones which are busy, maybe we will not deploy your instance on that server, but we will deploy them on like less easy and more available server, which has more resources. So yeah, like we basically match each instance with one of the servers in the pool and assign it to it, and then run the instance on that server.
Okay,
was that the question? Did I understand?
And one final question. So let's say like before scaling, we have this user service running on this Dodo infrastructure.
Yeah.
And does it mean that this user service, as part of this whole Dodo infrastructure, is also running on other servers as well? Or once we request scaling, only then other server Dodo instances will get this user service?
Yeah, only then. Like by default, we launch it only on one server. If the user requests more instances by changing the app queue file, then we will react to it and launch it on the more servers. But there will be a Boolean field in the configuration or on the UI, which if you check, saying that like auto scale, let's say, then the system will react automatically on the incoming traffic. So if the traffic increases very quickly and there is not enough instances of your application running already, we will launch new instances automatically to react on the load increase. And once the load goes down, we will stop few instances to match the new load on the system.
By the way, regarding this autoscaling, I think Vercel has this very popular problem with autoscaling that if you don't configure it right and you just let autoscaling have no limits, when there is some attack or some high load, it will just crush your fees and you'll get bankrupt or something. And have you thought about that?
Yeah, for sure. Like autoscaling will not be like without bounds. So users will be able to define like a lower and upper bounds to the scaling. So upper bound is more common to use because you don't want like millions of instances running. So which will cause like your balance check to increase, and you'll have to pay a lot of money to the company. So that's more like first thing users require usually. So obviously, yeah, we will have a upper bound way to define the upper bound basically for each instance. But you can also save money by properly defining the lower bound of the number of instances. For example,
Yeah.
let's say your application, you develop some application for USA or Europe, let's say Europe, right? So people living in Europe, like usually, I mean, in general, most of the people will use your application during the day, and at night the traffic will go down. And depending on the type of the application, traffic can go down to completely zero if your application isn't really entertainment. No one is really doing the work at night, so traffic will go down to zero. So at that point, there is no reason to run an instance of your application at all at night and pay for the CPU and disk for no reason. So what will Dodo do is automatically, if it detects that for some period of time that traffic is zero, it will actually kill all of the instances, but still continue listening to your application's endpoint. So as soon as users wake up and start using your app, it will automatically bootstrap the new instance and will serve the users, but you will have made like a pretty significant cost savings during the night, I think. So yeah, so we will have both upper and lower bounds, which help in different ways, but I think both are important.
And I think like in the beginning of our conversation, you mentioned that all those applications inside Dodo can interact with each other. So can you just tell us how that happens from this picture? I mean, like two services, how do they talk with each other?
So by default, obviously we take security seriously, and no one should really trust me on this word. And one of the reasons the project is open source is so that people can independently audit it. But also we will do some pen testing later on. But yeah, we have everything, like the whole system is secure by default, which means two different things. So you have to think about security in the context of running one instance of the application, meaning it cannot first escape from the sandbox and affect the physical server in a bad way, or reach out to a different service to which it doesn't have permission to, and other way around, like no one else should be able to, other services shouldn't be able to reach into you and read your memory. So every application runs in the sandbox by default with the limited capabilities, and we use Google's open source project gvisor for this, which is kind of a lightweight virtual machine, let's say. And also every application, like first, every instance of the Dodo gets its own virtual network, like VLAN. So one instance of Dodo cannot talk to the other instance of the Dodo, meaning, I mean, they can still reach each other on the public and domains endpoints. If they publish some applications globally, then anyone outside of Dodo and
Yeah, but that's not your concern, right?
Yeah,
if something is public.
Yeah, exactly. But internal services are completely locked down. So like one instance cannot reach into the another instance's internal services because we have like networks separated from each other. They can't even find each other, and the traffic will be blocked if they try to send some packets to another instance. And also within the instance of the Dodo, all these applications are also separated, meaning they also have like their own, I mean, they are living under the same virtual IP subnet, but traffic between the services is blocked by default only if user requests that one application needs to access another application and allows it from the app manager, then only then the Dodo will let that traffic go through and let those two services talk to each other. So there are some services which need to talk to each other by default. For example, this authentication and membership service is used by everything else pretty much to figure out who is logged in and what kind of capabilities, permissions that user has. So by default, you get some access outside of your instance to only like very limited number of services. But if you need more, then you have to ask for it and user has to approve.
And so, for example, just very human, real example. So we have, let's say, like one app service running, and you're saying that I can deploy some malicious software, right, with Dodo app, for example. And you're telling me that it cannot affect anything else in this whole infrastructure, any other node, right?
Yeah, that's completely correct. So even if the user is malicious and installs some like knowingly installs some virus or some malicious software on the system, hoping that it can reach into the network and steal other users' data, even that is blocked, so they will not be able to reach out. Applications will be locked down into their own kind of sandboxes. And also maybe there is some third-party developer who snuck some malicious code into the software and is now publishing in the App Store, which then other users use unknowingly, which is pretty common, I think, in every App Store. That thing happens. It's hard to control everything. So even in that case, we will, not let that application reach out to anything it's not supposed to, basically. And there are ways to lie to the user, but if we make all these permissions transparent and resurface them onto the UI to the users to approve, or the system administrators to approve or block, then I think at least we have some tools to save ourselves from the some data leakage. But it's still possible, like by social engineering. But yeah, on a technical level, I think we have all the tools we need to be safe.
One last thing I want to ask is that you showed me this tree-like structure, right, in this Paint application or something, but it's still too abstract for me right now. Can you talk a little bit about implementation details? I mean, how is that tree represented technically in this infrastructure project?
Yeah, so one of the nodes in the tree I mentioned was the state reconciler. So what the state reconciler does is pretty much like takes this tree and translates it into the actual Kubernetes resources. And this tree itself is represented as a file system in the Git repository. So there are multiple types of nodes present in the tree. So every directory gets its node, and every file in that directory or other directories in that parent directory become child nodes of the parent one, current directory. So every tree is a file system, and this file system gets committed to Git repository.
And what about the backward relation? I mean, when I want to go from child to top, how is that represented in file system?
You usually don't. So there are, I showed arrows in the picture, but those arrows are more of a, so each service can request access to another service. And if the user grants that, then we pass down so this child node, one of the nodes requested access to another node. So this first node in the configuration gets address of the second one. And between these two nodes, we implicitly create this connection, which translates into the network access, basically. But there's no like direct relationship between these two nodes. So platform, like the core infrastructure, which is shared between all the instances of the platform, has its own Git repository. Then separately, each instance of the Dodo has its own Git repository. And to go from one repo to another, in the parent repository, there exists the file with the information of how to access the child tree's repository, like its address and the user credentials, so that we can log into that Git repo and read the state of that subtree. And so this is a technical representation. Like there's a file system with different types of files, and each type of file is translated into corresponding Kubernetes resource. But so this is pretty simple, I would say, but the fact that this file system gets committed saved into the Git repository enables a pretty interesting and I think very useful feature to the system. So first you have by making changes in the tree, you are creating actual commits in the Git repo. All of this happens under the hood. Users don't actually see it, but there is with every install of the application, new commit gets created and then pushed to that corresponding repository. So first you get the history out of the box. So you can look at the history of the commits and figure out how the state of the system evolved. And if there is something wrong, you can figure out where that happened, like at which stage. And then you have multiple ways of addressing it. You either create a new commit and fix the old mistake you made, or you can, if it's a mistake where it can't be addressed by simply overwriting things, you can always just roll back the commit and get back to the working state at some commit in the history. So yeah, I think that's a very valuable thing, especially where third-party developers get involved. Like someone can always publish some malicious software, and even though they cannot technically affect anything in the system, there can always be bugs. There can always be made mistakes by the user by letting that application granting that application access to some other node in the tree. So if that happens, we can always find a commit before which this malicious software didn't exist in the system, and just roll back to that state and push it that way to the Git repo, and the state reconciler will pick up the new state of the Git repo, delete all the stuff which doesn't have to be in the cluster anymore, and restore the platform to the state user wants, basically. And we get that functionality out of the box. We didn't have to implement anything smart really about it.
Yeah. And like one thing I like about this Git is that you can kind of distribute this state across as many servers as you want, just by simply getting this Git repo right in that server. That's it. So the whole state.
But each instance of this Git repo is itself distributed, like the storage is, like the state of that Git repo. We have like multiple replicas of that state. But you can. One more useful feature we get out of the box by having the logic like this is that we try. First we are open source, right? But we also, software can be open source, but still try to lock in the users using some hosted version of it. So obviously, me as a potential company owner and trying to make money out of it, I'll have a hosted service which will be paid and will be much easier to start up with for the users. But if at some point one of my paid customers decides they don't want to pay me anymore and they have in-house knowledge good enough so that they can run their own Dodo platform on their own physical servers and save cloud costs, they can always export their state by cloning their instance commit history and pushing it into their own Git repo, and
that's pretty amazing.
And the Dodo running on that server, like listening to that Git repo, will spin up everything you had on the hosted version and transfer data back to you basically on your physical servers.
So basically,
we get the functionality like out of the box as well.
So actually, like I really, really love this idea of Git and using Git as some kind of this storage thing. So that's pretty amazing. So thank you.
Git is very cool. Like it's maybe wasn't intended for things like this, but once you understand how Git works, then your mind just starts lighting up. There are like lots of things you can use it for.
There are lots of interesting stuff hidden in this .git directory. So I think I explored it. I was exploring it like in the past, and I encourage everyone to get into it and see all this stuff, how Git itself stores these files and commits. So thanks, Lekwa, once again. I think we can slowly go to the end of our conversation because we just listened to lots of new stuff. I learned lots of things today. Thanks for that. And if you want to add something, feel free.
Not much. I mean, we can talk about this like whole day or even like multiple days.
Obviously.
But I think we covered the most important things. There are like lots of technical details we could go to, but doesn't make sense, at least on this talk. Maybe we will meet again in a few months and update the progress and also dig deeper into the infrastructure.
Okay, awesome. And I think I will remind our listeners that you're kind of doing this beta testing, we can call it like this, of your project right now. And anyone who will be interested, I will leave your contact and my contact as well in the description. So feel free, guys, to reach out to us. And yeah, I think, and even ask some more technical and deep questions to Lekwa and myself as well. So thanks again. I had, obviously, I don't, I even though I'm a software engineer, I don't always learn and like talk about these deep technical things. So thank you for that, and wish you all the best and good luck.
Yeah, thanks so much. Thank you for inviting me and giving me the space. If anyone wants to try, now I think it's pretty stable to give it to the external users. So yeah, just reach out, and I'll be more than happy to explain things and give access to anyone.
Awesome. Bye.
Yeah, thank you again.